Hello, everyone. My name is Keith Jackson, and welcome to Jack's Math Notebook. Right now, you're looking at the third video in a series of videos related to transforming the parent function. All right, and the parent function that we're going to work on today will be the identity function known as function of x is equal to x. And here's why, in this case, function of x is equal to x is because as we move along the x-axis, let's say to the right, let's say we move to 1. If we go up, we find that the y value will be 1, or the function of x value will be equal to 1 as well. All right, and this is why function of x is equal to x. And with that in mind, the domain will be all real numbers, because as you go to the left towards negative infinity, it will be all real numbers to the left, and it will be all real numbers to the right as we move right along the x-axis as well. And so the domain again will be all real numbers. The same is true for the range. The range will be all real numbers because as you move up along the y-axis, it goes to infinity. And then same thing is true as you move down along the y-axis to negative infinity as well. And this is why the range covers all real numbers. And let's go ahead and transform this function by adding a 2 to the function. All right, so now we're going to say function of x is equal to x plus k. And so if you recall from previous videos, k allows the function to move up and it allows the function to move down. And so in this case, when we add a 2, the function moved up 2 places right here. All right, and again, the domain will be all real numbers and the range will be all real numbers, even though k is equal to 2. And let's move on to the third transformation of the identity function, in which this time we're going to subtract 2. So k is equal to negative 2, so it's going to move the function down 2 units right here. Okay, showing that the domain will be all real numbers and the range will be all real numbers as well, because in this case we have function of x is equal to x minus k. Now let's move on to the fourth transformation, in which we have now we involving h. And so now we have function of x plus h is equal to x plus h. And this has something to do with the horizontal movement of the function right here, of the identity function. Again, it's going to be the domain will be all real numbers and the range will be all real numbers. And notice how when I added 1, it just moved the function back 1 place right here. And again, here's what's interesting. The y-intercept is at positive 1, but it kind of moved the function back a negative 1 unit right here. And so and this is why when we see this particular function, x plus 1 actually moves it back 1 unit to the left. All right, and let's move on to our next example of the identity function, in which we're going to subtract 2. So now we have the function of x minus h is equal to x minus h. And when we move move it over, right, when we subtract 2 from it, it's actually going to move it down, move it over to the right 2 units. Notice how our y-intercept is at negative 2, but when it crosses our x-intercept is at positive 2, showing that there is a movement toward the right. Very interesting thing to notice about this particular function. Okay, you have received a lot of information about this particular parent function and its transformations, and I wouldn't blame if you need to pause the video to take a look at all the movements of this function, or replay this video as many times as you need to gain a deeper understanding of transforming parent functions. And with that in mind, please comment, share, like, and subscribe to Jack's Math Notebook for more content. Thank you, and bye.